The Habsburg jaw. A result of incest. How did the powerful European dynasty decline? The distinct deformation of the lower face, typical of the European royal Habsburg dynasty, is due to incestuous marriages over several generations. The anomaly, known as the Habsburg chin, is evident in portraits of the dynasty's members, both women and men. The lower jaw juts out significantly, while the upper jaw looks underdeveloped. Historians have long suspected that this Habsburg family trait was due to a series of close relative marriages. Now, these suspicions have scientific backing from Spanish doctors who studied numerous portraits of the dynasty's members and created an extensive genealogical tree of the Habsburgs, spanning over 20 generations. The Habsburgs were the most powerful royal dynasty in Europe for much of the Middle Ages and the early modern period. Members of this family united vast territories in Western, Southern, and Central Europe under their rule. The lands they ruled at various times are now part of Spain, the Netherlands, Germany, Italy, the Czech Republic, Austria, Hungary, Romania, Ukraine, and many other countries. The Habsburgs achieved such power largely thanks to numerous marriages within the ruling dynasty, which helped avoid the fragmentation of territories during inheritance distribution. The most striking example of such incestuous policy was King Charles II of Spain. His father was his mother's uncle. The mother herself was born from a marriage between cousins, who in turn were also born as a result of inbreeding. 6 out of 8 of Charles's great-grandparents were descendants of Joanna the Mad. His inbreeding coefficient, the crossing of closely related organisms, was 25%. This is the same level as children born from direct incest between siblings. Charles was disabled from birth with a range of illnesses and left no heir. Close relative marriages are legally prohibited in most countries. This is because they significantly increase the risk of developing congenital diseases. Parents who are related can pass the same defective gene to their child, and this probability increases with the closeness of the relationship. Family deformity. Spanish scientists collected portraits of 15 members of the Habsburg dynasty, a total of 66 images, and showed them to 10 practicing maxillofacial surgeons, asking them to assess the degree of facial deformation of the depicted people. In parallel, historians compiled a detailed genealogical tree of the Habsburgs, containing over 6,000 people from more than 20 generations. To most accurately assess the degree of kinship between them and the level of inbreeding of a particular ruler, the surgeon's assessment result was predictable. The more relatives among a monarch's ancestors, the more pronounced the abnormal facial features were, especially the protruding lower jaw. The least deformed face was that of Mary of Burgundy, who married Maximilian of Habsburg, the future Holy Roman Emperor, in 1477. The lower jaw anomaly was most noticeable in Philip IV, King of Spain and Portugal. Although our research is based on historical material, prevalent in certain geographic regions and among specific religious and ethnic groups, it is important to study its consequences even today. The Habsburg dynasty serves as a kind of laboratory for this, as the level of inbreeding in it is particularly high, concludes the lead author of the study, Professor Roman Vilas of the University of Santiago de Compostela. Tutankhamun and the inbreeding of ancient Egyptian pharaohs. Ancient Egypt has always fascinated with its grandeur, architectural achievements, and mystery. One of the most famous figures of that time is the young pharaoh Tutankhamun, whose tomb became a true sensation in the archaeological world. However, many secrets are hidden behind this figure. One of the most intriguing topics is the inbreeding in the pharaoh's families and its impact on the health and life of Pharaoh Tutankhamun himself. Pharaohs were considered not just rulers but true gods on earth. They were representatives of divine will, and that is why dynasties tried to preserve the purity of their bloodline. Marriages between brothers and sisters or close relatives were common, as it was considered a way to maintain divinity and hereditary rights to the throne. But such a policy had its dark consequences. Frequent marriages between close relatives led to very limited genes among the pharaohs, and this caused serious genetic inbreeding, leading to various physical deformities, chronic diseases, and weakened immunity. Health problems might have been invisible to contemporaries, but left pharaohs vulnerable to early death. Tutankhamun, perhaps the most famous pharaoh of ancient Egypt, became a ruler at the age of just 9 and reigned for only about 10 years. He was the son of Pharaoh Akhenaten, and likely one of his sisters. Such a marriage aimed to preserve blood purity, but it also meant a high risk of hereditary diseases. According to genetic studies, Tutankhamun had numerous physical problems, bone deformities, congenital food defects that made walking difficult, as well as other diseases, including malaria. Modern studies of Tutankhamun's mummy show that he had several genetic defects. One of the most noticeable was a bone disease, congenital clubfoot, which forced the young pharaoh to use canes for walking. Additionally, traces of malaria were found on his mummy, which could have worsened the pharaoh's weakened health. These problems severely limited his physical abilities and could have contributed to his early death. Tutankhamun died at the age of just 19. His early death remains the subject of numerous studies. While some scholars believed he might have died due to an accident or even murder, genetic and medical data suggest that his death was likely caused by a combination of his physical ailments and a serious infection, possibly malaria. The story of Tutankhamun is not just about a young pharaoh whose tomb amazed the world. It is also an important reminder of the terrible consequences of inbreeding, the dynasty. Practice of Egyptian pharaohs led to serious genetic problems that significantly affected their health and lives. And although Tutankhamun reigned briefly, his legacy will forever remain in world history as an example of the impact of heredity on the fate of rulers. The tangled bloodlines of the British monarchy. The British monarchy is known for its immense influence on the history of Europe and the world. However, behind the centuries-old history of this dynasty lie tangled bloodlines, where political and dynastic alliances made close relative marriages the norm. Today we will examine how these tangled blood ties affected the development of the royal family, its political stability and genetic heritage. The origin of the Windsor dynasty. The modern British royal family is known as the Windsor dynasty. The Windsor dynasty traces back to the House of Saxe-Coburg and Gotha and earlier to the Hanoverian dynasty. In 1917, during World War I, King George V changed the German surname to Windsor to distance from German roots during the conflict with Germany. However, in reality, the Windsor dynasty has complex and mixed bloodlines that encompass almost all European royal families. Queen Victoria, the grandmother of Europe. One of the key figures who tangled the bloodlines of European monarchs was Queen Victoria. She is called the grandmother of Europe because most European royal families trace their lineage back to her and her husband Albert of Saxe-Coburg and Gotha. Victoria had 9 children who married into royal dynasties across Europe, creating a strong network of alliances. Victoria's descendants occupied thrones in the United Kingdom, Germany, Sweden, Norway, and other countries, strengthening political ties between European monarchies, but also spreading hereditary diseases, particularly hemophilia. Hemophilia, the legacy of Queen Victoria. One of the most famous genetic legacies of Queen Victoria was the disease of hemophilia, which was passed through her children and affected several royal families. This life-threatening disease complicates blood clotting. This disease became a symbol of how deep and tangled the bloodlines between European monarchs became due to frequent marriages between relatives. Inbreeding in the Hanoverian dynasty. The Hanoverian dynasty, from which the British monarchs of Windsor descend, also had problems with inbreeding. King George III, known for his long reign and mental illness, likely fell victim to dynastic marriages between close relatives. Historians believe that his illness, porphyria, which caused bouts of mania and depression, could have been hereditary and exacerbated by inbreeding. George III's illness had enormous consequences for British politics, as his mental disorders led to a governance crisis that affected the course of the American War of Independence. Elizabeth II and modern monarchs. A new approach to marriages. Unlike their ancestors, modern British monarchs avoid marriages between relatives. Queen Elizabeth II and her descendants married people outside royal families, which helped expand the genetic base and avoid the risks associated with inbreeding. For example, Prince William married Kate Middleton, who comes from an ordinary family, which marked a change in royal traditions. The impact of tangled bloodlines on the modern monarchy. Although modern British monarchs have significantly moved away from the practices of their ancestors, tangled bloodlines continue to affect their lives and legacy. Complex genealogical connections remind us of times when politics and dynastic alliances were more important than the health of future generations. The history of the British monarchy demonstrates how the interaction of politics and genetics influenced the fate of one of the world's most famous dynasties. Inbreeding in the animal kingdom. Natural consequences and adaptations. Inbreeding in large predators. Large predators, such as lions and cheetahs, sometimes fall into the trap of inbreeding due to isolated populations. Cheetahs, for example, experienced a significant population decline several millennia ago, leading to critically low genetic diversity. This makes them more vulnerable to diseases and reproductive issues. In lions, inbreeding can occur in isolated prides, such as in the Ngorongoro National Park in Tanzania. After a disease affected most of the population in the 1960s, a small group of lions survived the crisis. This led to marriages between relatives and a decrease in genetic diversity. Inbreeding in small populations and islands. Isolated island populations, such as Komodo dragons or Galapagos penguins, also face inbreeding. Due to the limited number of mating partners, these species face the danger of passing on genetic mutations and reduced offspring viability. For example, on the island of Madeira, there is an isolated population of mice that has undergone numerous waves of inbreeding. Although such populations often have adaptations for survival in conditions of low genetic diversity, they also remain vulnerable to environmental changes or new diseases. Positive aspects of inbreeding in the animal world. In some animals, inbreeding has positive sides and even plays an important role in social structure. For example, in social insects like ants and termites, inbreeding is often observed because the queen mates with several males who may be her relatives. This ensures the continuity of genetic lines and population stability, as all colony members share common genes, which contributes to their collective survival. Inbreeding in endangered species. Inbreeding is also a serious problem for endangered species. In small populations where the number of individuals is limited, inbreeding is often the only option for the species' survival. However, this makes animals vulnerable to genetic defects and reduces their ability to adapt. For example, Amur tigers face the problem of reduced genetic diversity due to the small number of partners. This can lead to reduced offspring viability and the threat of complete species extinction. Survival strategies and combating inbreeding in nature. In nature, there are several mechanisms that help avoid the negative consequences of inbreeding. Some species have adaptations that allow them to migrate long distances, seeking new mating partners. Others have complex social structures that reduce the likelihood of mating between close relatives. Genetic pulses in isolated human communities. Human genetics is not simple. It is a complex and mysterious process that determines not only our appearance but also many other aspects of our lives. In remote and isolated human communities, where communication with the outside world is limited, genetic pulses have a special impact. How do genetic drift and inbreeding affect these communities? What diseases and adaptations arise in such conditions? And is there a way to avoid the harmful consequences of isolation? Genetic drift and its role in small, isolated communities. Genetic drift is a phenomenon that significantly impacts isolated communities. Due to the small population size, certain genes are passed down from generation to generation with greater fluctuations than in larger populations. It can lead to rare genetic traits becoming very common, while others disappear. As a result, these communities often see a concentration of certain genetic diseases, isolated human communities and their genetic traits. Isolated communities, like the Amish in North America or residents of remote mountain regions, exhibit unique genetic characteristics. The Amish, for example, are known for their isolation from the modern world and limited marriage circles, leading to a high prevalence of rare genetic diseases like Ellis-Van Creveld syndrome and muscular dystrophy. Residents of remote islands like Pitcairn or Tristan da Cunha also face issues related to small genetic pools, the impact of inbreeding on the health of isolated communities. In small isolated communities, there is often no choice for marriages outside the community, increasing the likelihood of inbreeding. This leads to recessive genetic diseases becoming more common. For example, in the Amish community, genetic diseases that are rare elsewhere in the world are more common. They have a higher likelihood of passing on hereditary diseases due to the high level of relatedness among community members. Genetic drift in indigenous peoples. Many indigenous peoples, such as the Eskimos, Amazonian tribes, or Australian Aborigines, also experience genetic drift. Lack of access to modern medicine and limited genetic resources lead to the spread of specific genetic diseases. However, some communities have developed unique adaptations to their living conditions, like the Eskimos, who have metabolic traits that help them survive in Arctic cold. Positive aspects of isolation, unique genetic adaptations. While genetic isolation has many risks, it can also create unique adaptations. For example, the Sherpa community living in the Himalayas has genetic adaptations that allow them to better handle high altitudes and reduced oxygen levels. This is the result of long-term natural selection in isolation. Similar genetic adaptations can be observed in other communities living in challenging natural environments. This suggests that isolation is not always a negative factor. It can foster the emergence of new beneficial traits, the future of isolated communities, and genetics. Today, science is increasingly focused on studying the genetic characteristics of isolated communities. Geneticists aim to understand how isolation affects the health and evolution of these communities and find ways to prevent hereditary diseases. An important area of work is ensuring access to modern medicine and creating programs that help preserve genetic diversity even in remote communities. Modern tools that protect us from inbreeding. Inbreeding is a natural process that can have serious health consequences for offspring. However, thanks to modern science and cutting-edge technologies, we have tools to help avoid this phenomenon. From genetic tests to DNA editing technologies, we have many ways to ensure a healthy future for the next generations. How do these technologies work, and how do they help protect us from inbreeding? Genetic testing and its role in preventing inbreeding. Genetic testing is one of the key tools that allows assessing the risks of inbreeding and hereditary diseases. Modern genetic tests can identify recessive genes that may cause hereditary diseases if both parents carry the same mutated gene. The procedure is simple. Using a saliva or blood sample, a lab conducts a DNA analysis to determine the presence of dangerous genetic mutations. If partners are at risk of having a child with a serious hereditary disease, they can make informed decisions about family planning or choosing other options. Genetic counseling. Assistance in making important decisions. Genetic counseling is another important tool in combating inbreeding. It is a process where geneticists help people understand the results of genetic tests and make informed decisions about their offspring. Genetic counselors provide information about the possible risks of passing on hereditary diseases, treatment options, or prevention. This gives people the opportunity to better understand their genetic heritage and make responsible decisions about their health and the health of their children. Reproductive technologies. Innovative solutions for healthy offspring. Modern reproductive technologies such as artificial insemination, IVF, and pre-implantation genetic diagnosis allow avoiding genetic diseases associated with inbreeding. Pre-implantation genetic diagnosis allows examining embryos for genetic mutations before implanting them into the mother's body. Thanks to this, couples with genetic risks can be assured that their children will be free from serious hereditary diseases. This approach reduces the risks associated with genetic relatedness between parents, gene editing technologies, CRISPR, and a future without genetic diseases. One of the most innovative technologies in combating inbreeding and hereditary diseases is CRISPR. It allows for precise removal or correction of defective DNA segments that can lead to genetic diseases. It is used for research in treating hereditary diseases. In the future, this technology may become available for widespread use. It opens up prospects for gene editing even before birth, which can prevent the transmission of dangerous genetic mutations to future generations. Genetic profile databases. Global collaboration to prevent inbreeding. Another modern tool is global genetic profile databases. These databases contain information about the genetic characteristics of people from different countries and communities. They help doctors and geneticists identify potential inbreeding risks, especially in small populations or isolated groups. Thanks to global collaboration, scientists can identify dangerous genetic mutations at early stages and provide recommendations on how to avoid risks. This reduces the possibility of genetic problems in future generations and supports the health of people in different parts of the world. Thanks to modern genetic technologies and reproductive tools, we have the opportunity to prevent many genetic diseases that arise from inbreeding. Genetic testing, counseling, gene editing, and reproductive technologies provide us with tools to protect future generations. Science continues to advance, and we can be confident that with new discoveries, humanity will be able to avoid many genetic risks. How do laws shape the landscape of inbreeding? Throughout human history, inbreeding has raised not only medical but also social and ethical questions. How do the laws of different countries attempt to prevent inbreeding, protecting the health of future generations? What legal restrictions exist regarding marriages between close relatives? Laws against marriages between relatives? Most countries around the world have clear laws prohibiting marriages between close relatives such as siblings, parents, and children. These laws exist to minimize the risks of inbreeding and reduce the likelihood of passing on recessive genetic diseases. For example, in many European countries, marriages between cousins are prohibited, while in some countries, these marriages are allowed with restrictions. Religious and cultural aspects of legislation. In some countries, cultural and religious factors also play an important role in shaping laws about inbreeding. For example, in some Muslim countries, marriages between cousins are allowed as they align with local traditions and beliefs. However, even in such countries, there are strict medical requirements to ensure the health of offspring. In such cases, the state often requires genetic testing before marriage, medical legislation, and reproductive technologies. Modern laws on medical technologies, such as artificial insemination and pre-implantation genetic diagnosis, also contribute to preventing inbreeding. In some countries, mandatory genetic tests are provided for couples planning to have children through reproductive technologies. This allows identifying genetic risks and preventing the birth of children with serious hereditary diseases. Ethical issues and future laws. Laws regarding inbreeding often raise ethical questions. Does the state have the right to interfere in personal relationship matters? How can the rights of citizens be balanced with the need to protect public health? Modern legislative bodies discuss how best to regulate genetic testing and reproductive rights to avoid inbreeding issues and ensure an ethical approach to the matter. Laws regarding inbreeding play an important role in ensuring the health of future generations. They reflect not only scientific data, but also the cultural and ethical norms of each country. Technological progress continues to shape the future of these laws, making the fight against inbreeding more effective. Genetic disorders in inbred populations. An example of an inbred population could be a small isolated community where marriages between relatives become common due to the lack of external partners. Such populations may have a range of genetic disorders, such as autosomal recessive diseases, where both parents pass on an abnormal gene, leading to conditions like cystic fibrosis, phenylketonuria, or sickle cell anemia. Reduced immunity due to genetic uniformity, the population may lose the ability to effectively resist infections. It is especially important to understand that the less genetic diversity a population has, the greater the risk that these diseases will become widespread. Inbreeding issues in zoos and conservation programs. As many animal species are on the brink of extinction, conservation programs play a key role in preserving their populations. However, due to the limited number of individuals available for breeding, inbreeding becomes a serious issue. Main inbreeding issues in zoos: reduction of genetic diversity. As many zoos breed animals in closed systems, related pairs may reproduce, leading to the degradation of the genetic pool. The emergence of physical and behavioral anomalies. Fertility issues and physical defects are often observed. For example, the white tiger, often used in zoos, is a result of inbreeding, and such animals often suffer from blindness, deformities, and other problems, increased vulnerability to diseases, as in human populations, animals due to inbreeding have a reduced ability to fight infections and viruses. Conservation programs. To combat inbreeding, special programs are developed that use a scientific approach to animal breeding. One example is the cheetah conservation program. In wild cheetah populations, inbreeding was a serious threat, so scientists began using artificial insemination technology and exchanging genetic material between different populations. It is important that such programs consider genetic diversity, otherwise all efforts to preserve the species may be in vain. Depiction of inbreeding in literature and media. Inbreeding also finds its reflection in culture, particularly in literature, film, and mass media. This topic often evokes many emotions as it is associated with the violation of social and moral norms. Inbreeding in literature. Inbreeding is often used as a symbol of degradation or degeneration in literature. For example, in Henry James's work The Golden Bowl, inbreeding symbolizes the moral and physical degeneration of the aristocracy. In Fyodor Dostoevsky's novel The Brothers Karamazov, the theme of genetic connections and heredity is addressed. Although not directly about inbreeding, it is about the role of family ties in the fates of the characters. Inbreeding in cinema. In cinema, inbreeding also often appears as a disturbing and distorted theme. For example, the film The Hills Have Eyes depicts a mutated family suffering from genetic deformities due to generations of inbreeding. Such images amplify fears and stigmatization of inbreeding, though they are largely exaggerated. Inbreeding in the media. In modern news, inbreeding can be a topic for discussion in the context of genetics or social norms. The media often covers such topics to draw attention to specific cases, like isolated communities or dynastic marriages. Thus, inbreeding is a phenomenon with serious genetic consequences for both humans and animals. In zoos and conservation programs, it threatens species diversity, while in culture, inbreeding is reflected through moral dilemmas and troubling social issues. To avoid the negative consequences of inbreeding, science and society must collaborate to create programs that protect the genetic health of populations. This is an important task that requires attention and effort from biologists, ecologists, governments, and the public. If you found this interesting, leave a comment under this video about whether you like this kind of content and share your thoughts on it. Also, don't forget to like and subscribe to the channel. It really helps us out. Thank you.